was. It's not really required. I just wanted to fill in some information that I either skipped over or that I mentioned but I didn't go into, something like that. So I'll be talking about two things in this video. One is going to be modifiers, things like public, static, things like that. And the other is going to be types. So far we've only used integers and floats in our code, I think. We've used strings too, but those aren't primitives, that's just an object. So I'm going to go through all the different types, and I'm going to go through all the different modifiers that methods and variables can have. And I'll probably also go through some of the other reserved words in Java, or maybe I'll go through all of them. You do not need to know all of this, but if you pick up a little bit of it, it'll help you. Particularly the things I'll talk about first. So let me actually make sure that the stream is picking it up. Okay, good. I got things in a different orientation on my screen because I have like a little cheat sheet open, which I usually don't have open. It's just a list of all the keywords in Java because I can never remember them all. There's 50 of them. It's hard to just name them off, rattle them off. And for most of these I'll probably use examples. So why don't we get right to it. So let's start with what we see on the screen. Package. You're probably wondering what this package thing means since it's been in all of your files. In Java, a package is basically just a folder of Java files. So I'm telling Java that this class, this test project class, belongs to the test project package. And so far that doesn't mean anything, but when you actually write Java code, you'll be wanting to import certain classes, which means you'll be able to use the code in those classes. Okay, you can't just use any Java code willy-nilly. You have to tell Java, okay, there's some code, I know where it is, I want to use that code. You have to tell Java to use that code. So if I wanted to use things that are in the same package as each other can see each other. So all these things we've made so far, the combat unit, footman, marine, test project, if you're watching this before watching part 3, we make these in part 3, these three things. But if I had another package, I'm not going to make one, but if I had another package, I would be able to import, you know, other package dot and then the name of the class. You know, some class. That's how I would use the code in that class if it was in this package. You would use it with import. So that's what package is, and that's what import is. Let's talk about what kind of modifiers variables can have, because there's a lot of them. So we already know two of them. We know public. We know, okay, I'm going to make all of these integers. We know public. We know private, although we haven't used private. There's a third one called protected. Every variable that you declare must, well, I'm not going to say it must. There is one exception. It should have one of these in front of it, public, private, or protected. A public variable can be used by any code. You can write any class. If the variable's public, every other class in the world will, you know, if they have your class imported, every other class can see this variable. Okay? If it's private, then only the class that it's in can see it. So if I have a private int b, and I were writing, you know, public void do something, I could write b equals 5, and this is allowed. But if I tried to write b equals 5 inside marine, for example, even if I passed in a test project, which is the name of this class. Usually you would not instantiate a class with a main, but you could. Even if I had a method like this, oh, I have to give it a name. Test, that's its name. I cannot access b equals 5. It's going to give me an error. But I can access test.a because it's public. Okay, that's the difference between public and private. A public variable can be accessed from any code. A private variable cannot be accessed from any code. It can only be accessed within the object that the variable is declared in. And a protected variable is a variable. Actually, yeah, I can do this. Let's make health protected. a protected variable can only be accessed by this class and any class that subclasses it. So any class that extends combat unit can also see this. So let me make this compile. I'll do health equals health minus 5. See, I'm allowed to do this because it's protected. So even though it's in combat unit, I can use the variable inside of Marine. But I can't use private variables inside of Marine. Let's say that move speed was private in combat unit. If I tried to edit move speed here, it would give me an error because move speed has private access in combat unit. That's the error that it shows up. Okay, so private means only this class can see it. Protected means this class and its children can see it, and its children's children. It goes all the way down. Public means anything can see it. Now there is a fourth one called default, although you don't actually type it. In fact, if you type it, it'll probably give you an error. Yeah. I wonder if this is allowed. It's not. Okay. If you don't put a modifier on a class variable like this, we don't have a modifier over here. We don't have a public or a private or a protected. If you don't put anything on it, it means that anything in that package can see it. Okay, so I can go to my test project, and if I have a combat unit, actually let's make it a Marine. I can do m dot, and see I can see the attack damage because anything in the package can use it. But if I had another package, I would not be able to see this variable. Okay? So there's public, private, protected, and people call this default, but it's just, or sometimes they call it package access for obvious reasons. Those are the 4 access modifiers: public, private, protected, and none, basically. So we're actually gonna make all of these default. Sometimes my mouse double clicks if I don't click it too hard, or okay, I'll just do it that way. So we're gonna fix all of our code, and we're gonna get rid of this because we don't need it, and we're gonna get rid of this because we don't need it. Okay. Let's talk about some other modifiers. You have already seen this one, static. A static variable. Static variables and static methods are kind of related, but not exactly. A static variable. First, let's talk about what a regular variable is. Where's my combat unit? So these variables are not static because I've not told them to be static. They're non-static, I guess is what you would call them. Meaning, when I create any combat unit, when I create a Marine or a Footman, each Marine has its own copy of this variable. So each Marine has its own health, each Marine and each Footman has its own attack damage, each Marine and each Footman has its own move speed, okay? But if I have a static int test number equals 5, a static variable doesn't belong to an individual object. It belongs to the entire class. So if you change the static variable on an object over here, it will also change on the object over there. Okay, so if you change it anywhere, it will update everywhere. And I will show you this in action. I've made it a package variable for a reason. So Marine A equals new Marine. Marine B equals new Marine. A dot, you access, actually I think I am allowed to do this. A dot, what did I name it? Test number? Is it not going to let me do it? Okay, you access, I guess they changed the way that Java sometimes works. I have to cough. That's better. I probably should have had a drink. Anyway, the way you access static variables is rather than type like a dot and then the name of it, you actually type the class name because the variable belongs to the class. So we would type marine dot test number plus plus. Plus plus just means add 1 to it. Okay? So when we create this class, in other words, when our program runs, it's going to be 5. We're going to add 1 to it. So if I do a dot print, I'm just going to make a print method on both of these Marines. Actually, why don't I put these prints up here? And then I'll put them down here as well. And all it's going to do is it's going to print test number on whichever marine it's called on. Public void print. Was it test number? Okay, so we're going to print out test number. So we've created marine A and marine B. We're going to print test number as A sees it, then as B sees it. We're going to increment it, then we're going to print as A sees it and as B sees it again. So here we go. It should be 5566. And it is 5566. So a static variable belongs to the class. If you change it anywhere, it changes everywhere in that class. Okay? That's what static means on a variable. Static on a method is kind of the same thing. It also belongs to the class. So you would call it, what's a good way to explain this? You would only make a static method if you don't intend to have an object to use it with. So, for example, is there anything... I can't think of an example with these kind of classes, but normally you would do it for like utility type of stuff, where you have an input and an output, but you don't need to create an object to do it. And a good example is Java's math class. Java has a class called math that's entirely static. Every variable and every function, every method is static. So math dot, and here they are. So math dot, you can get absolute value, arc cosine, add exact, arcsine, arctangent, ceiling, which means round up, cosine, we've got exponent, we've got all these nice mathematical things, but I can just call these on the class. So if I call math dot, max, and I put two numbers in, these are doubles. This is just going to return 20. Max returns the highest of the two. And I didn't need to create a math object. I didn't have to be like math m equals new math, right? I don't even think it's going to let me do it. It's not going to let me do it. Yeah. Wait, what? Oh, that's interesting. I didn't know that. There is a constructor, but you can't use it. So it's not going to let you do that. So you would write a static method for something like this, where you don't need an object to call it, because it belongs to the class. And you just call the method by using the class name and then dot method name. So that's what static does. Static variables belong to the class. Static methods belong to the class. There's only one copy of any static variable at a time. Okay, I can have 10 marines. They'll have 10 healths, 10 move speeds, but there will only be one test number. Okay, so that's static. Where was I? Oh, here we go. Let's see, for variables, there's also final. A final variable means that you set it when you declare it like this, and then it can never change. So it's basically a constant. You would use this for constants. So if I try to do a plus, or a equals a plus 5, it won't let me, because it says, a bad operand types, wait, what did I do? Oh, these are overwriting the thing. Now it'll give me the correct error. Cannot assign a value to a final variable. So a final variable is a constant. It's something that you create once. It lets you create it once, but it does not let you change it. That's what final means. It's pretty easy to remember. In C and some languages you'll see const. I don't actually know what const does in Java. It says it over here. Let me see. Const, it's a reserve. It has no function. Okay, const doesn't do anything in Java, but it's reserved anyway. What other modifiers? Let me see. Here's one. Volatile. This also does nothing, I believe, but it indicates that... I think it indicates that the variable could be used concurrently. I don't actually think it does anything like within the language. It's just kind of a marker to tell other programmers. Lots of different threads use this at the same time, possibly. Related to volatile, let's see, I'm not going to teach you that. What else is in here? I'm looking over at my little list. Can I make variables synchronized? I cannot. Alright, let's see. Public, private, protected, package. Oh, native. You don't need to know about that. Interface. I guess that's it for variables. Yeah, that's it for variables. So we'll save that. What did I break in here? Test number doesn't exist. We'll get rid of that. Alright, let's look back in combat unit. Because you'll notice I put this abstract up here. And I kind of explained this in the next video, I think, because somebody asked. If something's abstract, if a class is abstract, I believe classes and maybe methods, I haven't done it in a while, but let me see. What does it say? Okay, you can make methods abstract. An abstract class means people are not allowed to instantiate the class. So remember, there's classes and there's objects. You should probably watch part 3 before listening to this. There's classes and objects. You write your class, that's a template, and then you make your objects out of that class. If you make a class abstract, it means you cannot make objects out of the class. And you would only do this if you're subclassing it. So I have combat unit, which is abstract, which means we can never make a combat unit. But we can make Marines, and Marines extend combat units. So they get all the, the benefits of being a combat unit without being a combat unit. So that's what abstract means. It means you cannot make an object out of this class. When it's on a method, it's pretty much the same idea. Oh, I need a return type. When you have an abstract method, it means that, I wonder what happens, will it give me an error? It will. An abstract method means, again, it's very much like an abstract class. You can only use abstract methods in abstract classes. It means anything that subclasses this, anything that extends this, must have this method. But we're not going to tell you what this method does because each child can implement it differently. Okay? So you'll see over here on my Marine I'm getting an error because it's not Marine is not abstract and it does not implement all the abstract methods. So here's our abstract method, but we have to make our own implementation for it. Meaning we have to write our own code for it. Okay, so that's what an abstract method is. It means you're telling all of the subclasses you must have this method. Alright, so that's abstract. We did static. I think I can make this class final. You can make classes final. Maybe not. Oh, it can't do abstract and final. Final means you can't extend the class. Okay? It's kind of the opposite of abstract. Final means you cannot subclass this. So if I save this Marine, it'll probably throw an error. There it is. Cannot inherit from combat unit. Final variables, of course, means you create it and you can't change it. A final class means you cannot subclass it. Alright, let's look at any of these other keywords. We're going to handle loops in the next video, in video 4. Or part 4 is video 5. I guess now it's going to be video 6. It's going to be part 4. That's what it's going to be called. Const doesn't do anything. These are all looping things. We're not going to talk about enums. That's pretty much it. I think all I need to talk about now is the types. Oh, return. We already know what return does. It means something that's calling this method is expecting a value out of it. Return is how you get the value out of it. So when we call toString, we're expecting a string. So somewhere in this method we have to return a string. And this big thing is the string that we're returning. We're not going to talk about super. We don't need synchronized. Oh, this. You will use the keyword this sometimes. And here's how. You just do that. This means, as you might guess, it means this object. So you call this method on a combat unit. So you call it on a Marine. It just means that we're going to access the health variable on this object, whatever we have called this method on. That's all it means. It's the exact same thing as if I get rid of this. But the reason you would do it is, say you have a method that looks like this, where the variable name here is the same as the variable name up here. You can't just do health equals health. because this variable health is shadowing. It's in here, so it's a lower scope, so it takes precedence over this one up here. So you can still access you can still access the one up here by typing this. So if you were to do something like this, where two variables have the same name but are in different scopes, you'd still be able to access the one in the class by using this. So you'll see as I highlight the one, the health variable in front of this, it's highlighting the class level, but if I highlight the other one, it's highlighting the parameter. So that's what this does. You can also use it to call methods too. So I can call attack on, whatever, on null. Oh, null is another thing. You might be able to figure out what it means. It just means no object. So I have to pass something into this parameter. I can just pass null. I can't pass nothing, it's not allowed, but I can pass a null object. This will usually give you some errors, okay? Sometimes there are methods that let you do this, meaning it's like an optional variable, but you usually want to avoid using null. Sometimes you will have to, but you'll know it when you see it. I'm not going to really explain why you would use null on purpose. Alright, so that's pretty much... yeah, that's pretty much all the modifiers. So we got like abstract and static, final, and yeah. So now let's talk about some types. We talked about all the modifiers. We'll talk about types. So far we've run into integers. I'm just going to get rid of this for now. We've talked about integers. What's it complaining about now? It's not static. Forget it. And we've talked about floats, pi. I'm going to list all of the primitive types in Java, because everything that's not a primitive type is an object. Like string is an object, so that's not really a type. Okay, and I'm not even going to make them public. I'm just going to make it really easy to read. And I'm going to go in order. Boolean b equals false or true. Those are the only two values a Boolean can have. Next up is a byte, I believe. A byte is a 1 byte long number. So 2 hexadecimal characters right here, this is a byte. I can also assign numbers to them because actually I probably do 10. These two lines are identical because A in hexadecimal is decimal 10, which I've put here. Okay, so a byte is an integer. In fact, let me these are all some form of integer. So a Boolean is a bit, right? It can be 0 or 1, false or true, off or on, right? So that's 1 bit. A byte is 1 byte. Next up is a character, and there are many ways to denote characters. I can do it like this, or I can do it like this. Let me make sure this is right. I might be... where's my Ascii chart? As you may or may not know, yeah, double float. As you may or may not know, every letter, basically everything in your computer is an integer at some level. It's all zeros and ones, or hexadecimal, or however you want to think about it. 65 is uppercase A. I was wrong. It's not lower, it's upper. These two lines are exactly the same. So if I print out C, I think I'll get the letter A, but I have to make these static to use them. So it's gonna be C, and then we'll print out C2. I'm pretty sure they'll both say capital A, and they do. So in your computer, the number 65 represents capital A. The number 66 represents capital B, and you can find charts of these if you ever need them. They're called Ascii Tables or Ascii charts. That's ASCII. It's basically a standard model of... I write a recursive function in the next video, in part 3, where we talk about objects, I think. or maybe it's methods. It might be the previous video. But I do write recursive functions. We write a factorial function. So anyway, the letters and symbols, everything you type on your keyboard is represented by some number. Characters are how you store the numbers in Java. So these two lines are identical. Usually you would use this. You'd use single quotes and you'd put the character inside of that. Up from character is short. And shorts, I don't remember the max range. I think they go up to 32,000 something. Actually, let's find out. One of the good things about an IDE is we can just look at it. The max value for a short is 32,767. And here's the negative, or the minimum value right here is the negative, basically the opposite. But 0 counts as a positive. That's why this is 67. This is 68. So that's a short. An integer is the next one up. And the integer max value is like 2 billion, I think. It's 2.7 billion, I think. 2.1 billion, not 2.7 billion. How do you deploy a Java application? That's an excellent question that I will answer in a future video. But the short answer is, if you have an IDE like NetBeans, which we have here, I'm actually using JMonkey Engine, but it's the same thing. You would go to your project up here, you'd right-click, and you'd hit Build, or you'd hit Clean and Build. It generates a folder where your project is on your computer, and it has what's called a jar file. It's like Java's version of an exe. So that's what you do. You just build your project, and you give people the jar file. That's how you build a Java project here. Now, there are other ways to deploy Java projects, but this is pretty quick, and I don't know if we'll be using that, but you can use it. Next up from an integer is a long, and the long's max value is something ridiculously big. I don't even know what it is. It's this big thing right here, 9. Okay, so longs are really big, but usually people use integers because, you know, if you need to store anything larger than 2 billion, there's probably a better way to do your code. But every once in a while, you need to use a long. Alright, so these up here, these are all integers. All of them. They're just different forms of integers. Okay, they're whole numbers. Then we have floating points. So we've got floats, which we already know, and we've got doubles. Let's make double e equals 2.718. Do I need a d? I think I can put a d if I want, but you don't have to. Float and double are the same thing. Like shorts, integers, and longs, they have different ranges that they can store. A double can store bigger and smaller numbers than a float can. Typically float is good enough, but you'll notice that a lot of the math functions in Java will return doubles because they want to be very precise. Double is more precise. Double means double precision float. Okay, that's what it means. It's basically a double float. So I believe those are all of the types. Element HTTP has been asking me these questions. He types big integer really big equals new big integer, and he's typing something about big integers that I'm not really going to read. Big integer is an object that lets you store numbers that are basically bigger than these. Okay, if you need to work with really, really huge numbers, you would use a big integer instead of something like this. Because these have a max value, but you can write your code cleverly so that you can store a value of any size. Most of the time you won't need to, but if you're ever writing a program that's calculating huge numbers, like maybe you're calculating the number of stars in the universe if you're working at NASA or something, you might use a big integer, because that might not go higher than, actually I think it does go higher than a long, because it's like 10 to the 22, and the long max value is 10 to the 31. Okay, you could use longs for that, but there are things that you would use a big integer for. But that's an object, that's not a primitive type. I don't think I've missed any primitive types. Boolean, bytes, chars, shorts. Let me check my little cheat sheet over here. I don't think I missed any. Basically everything is going to be an integer or a float, or one of these variations of it. Boolean character, we got double, float, int, long, short. The last time I did this for my friend, I actually forgot about short because hardly anybody ever uses them. Yeah, so these are the primitives in Java. These are all of them. This is it. This is all of them. So when I say primitive type, it's one of these things that's blue. When you have a variable whose type is blue, basically, in this IDE. They probably change color in other IDEs. So that's primitives and keywords. I'm going to go ahead and probably end this video because I talked about everything I wanted to talk about. In part 4, are we up to? In part 4, we're going to be talking about loops and arrays, which are very useful. I think Gamer Coder brought it up yesterday, so we're going to talk about it because it's very important, and I almost